Welcome. The BoreCore archive is a collection of slow, methodical recordings of technical processes and perfectly boring routines designed to help you relax and fall asleep. New procedures are added regularly, so don't forget to like and subscribe. Time to relax, close your eyes, and take it on down to Sleepy Town.
Welcome to a complete operational guide to the visual inspection, documentation, and reporting of a newly constructed single-family residence, including the roof, exterior, foundation, structural components, electrical system, plumbing, HVAC, insulation, and interior finishes. Or everything the builder hoped you would not notice, systematically noticed. You are a certified residential building inspector. You work independently, under your own business name, having left a regional home inspection franchise 6 years ago to operate without the scheduling constraints and reporting templates that franchises impose. Your clients hire you directly, pay you directly, and receive your report within 24 hours. Your fee is $450 for a home of this size. You have no financial relationship with the seller, the builder, the real estate agent representing either party, or the mortgage lender. You work for the person who wrote you the check, and the person who wrote you the check is the person considering purchasing this house. Your certification is through the American Society of Home Inspectors, ASHI, and you hold a current license in this state, which requires 16 hours of continuing education per year and participation in the state's random audit program for inspection reports. You have been inspecting homes for 14 years. You have inspected approximately 3,200 homes in that time. You have inspected houses built in the 1880s and houses built last month. The house you are about to inspect was completed 8 weeks ago. It is a 2,300 square foot, 4-bedroom, 2.5 bath, single-family home in a new construction subdivision. The listing price is $428,000. The builder is a regional production builder that operates in 4 states and closes approximately 900 homes per year in this market. The prospective buyers, a couple in their early 30s purchasing their first home, have asked to attend the inspection. This is correct. The ASHI standards of practice recommend that clients attend their inspection, and you encourage it. Walking a client through a home and explaining what you are finding in real time is more useful to them than any written report, because the report describes defects, but the walkthrough shows where they are, what they look like, and how to think about their significance. The clients arrive at the same time you do. They are excited. This is understandable. The house is new, which means it has new appliances, new carpet, new paint, and a new smell that is specifically the smell of materials that have not yet been in a house long enough to reveal their problems. Some of those problems will reveal themselves today. You will find them. That is why you are here. Your equipment for today's inspection a digital camera, a moisture meter and electrical circuit tester, a non-contact voltage tester, a flashlight rated for a minimum of 200 lumens, a spare flashlight, a telescoping mirror, a carbon monoxide detector, a combustible gas detector, a ladder rated to 375 pounds for roof access, a 25-foot measuring tape, a level, a probe for testing wood for rot, a screwdriver with various bit attachments, a marble for testing floor levelness, knee pads for attic and crawlspace work, a Tyvek coverall for attic work, and a clipboard with your inspection checklist and blank photo log sheets. You also have your phone for additional photography and voice memos. The inspection will take approximately 3 to 3.5 hours. The report will be written tonight and delivered by 8 in the morning. The inspection follows a systematic route established by your practice and consistent with ASHI standards. Roof and attic first, then exterior, then garage, then interior room by room from top to bottom, then mechanical systems. The route is consistent because consistency prevents missed areas. You have used this route for 14 years. You have never arrived at the end of an inspection and realized you forgot to look at the roof. Let us begin. You arrive at the property at 9 in the morning. The house sits on a corner lot in a subdivision of approximately 80 similar homes, most of them completed within the past 18 months. The street is still partially under construction. Several lots further down the block remain unbuilt, and the curbs at the intersection have fresh concrete pours visible around temporary wooden forms. The subdivision's landscaping is minimal at this stage. The front yards have been seeded, and the grass is thin and patchy, the standard condition for a new construction yard that has had only one growing season. None of this is relevant to the inspection. You note the context and move on. Before approaching the house, you stand at the street and observe the exterior from a distance. This overview is not a formal inspection step, but a useful orientation. A distant view shows things that close examination misses, particularly regarding the roof line and the overall geometry of the house. You are looking for obvious deviations from level and plumb, visible sagging, areas of unusual discoloration, and any obvious installation anomalies visible from the street. From the street, you observe the following. The roof line appears generally straight and level, which is consistent with a new house. The ridge is straight. The eave line is straight. The gable ends appear plumb. These are favorable observations. You also observe that the vinyl siding on the left gable end has a visible waviness, a slight undulation in the lower 3 courses that is visible from 30 feet away in the raking morning light. You note this. Wavy vinyl siding is typically caused by insufficient nailing clearance for thermal expansion, or by installation over an irregular substrate. It is a cosmetic issue in mild cases, and a moisture infiltration concern in more pronounced ones. You will examine it closely when you reach the exterior. You introduce yourself to the clients who have arrived simultaneously. They are holding coffees and looking at the house with the expression of people who have already mentally arranged furniture in several of the rooms. You explain the process. You will move through the home systematically, narrating your observations as you go. You ask them to follow at a short distance, not touching or operating things before you have had a chance to evaluate them, and to feel free to ask questions at any point. You ask them specifically not to flush toilets or run faucets until you have checked the plumbing, and not to touch the electrical panel until you have evaluated it. They agree. You put on your boots, pick up your ladder and equipment bag, and begin. You set your ladder against the front eave and climb to the roof. The roof is an architectural shingle roof, a laminated asphalt shingle product that has a dimensional appearance mimicking the layered look of wood shakes. Architectural shingles are the standard product for residential construction in this price range, and are a significant improvement over the 3-tab shingles that were the norm a generation ago. They are heavier, more wind-resistant, and have rated lifespans of 25 to 30 years under normal conditions. The shingles on this roof are a commonly available architectural shingle product in a weathered gray color. The first thing you check is the installation pattern. Shingles must be installed with adequate headlap and side lap to prevent water infiltration at the joints. Headlap is the vertical overlap between courses of shingles, and side lap is the horizontal offset between the joints in adjacent courses. The industry standard for offset is a minimum of 6 inches between the joints in adjacent courses, creating the staggered pattern that prevents water from tracking through aligned vertical joints. You examine the shingle courses across the front slope. The offset pattern is consistent and appears correct. You examine the starter course, the first row of shingles at the eave, which should be a reversed shingle or a dedicated starter strip that provides a solid backing for the first exposed course. The starter course is present and correctly installed. You examine the nail pattern. Architectural shingles are nailed in a nail zone. A band across the shingle body, approximately 1 inch below the adhesive strip on the upper shingle, using 4 to 6 nails per shingle, depending on the local wind speed zone. Nails installed above the nail zone, called high nails, reduce the shingle's resistance to wind uplift because the nail is anchoring less material. Nails installed below the nail zone, called low nails or face nails, are exposed at the shingle surface and will corrode and work loose over time. You examine the exposed nail heads where the shingles are lifting slightly at several points on the front slope. You find 3 locations on the front slope where nails are visible at the shingle face, indicating low nailing. You photograph each location. You move to the ridge. the ridge cap shingles, the specially formed shingles that cover the peak of the roof where the two slopes meet, are installed correctly in terms of pattern. But one section of approximately 4 feet near the left chimney has cap shingles that are lifting slightly at their exposed edges. Lifted ridge cap shingles indicate either insufficient adhesive bonding, which can occur if the shingles were installed in cold weather before the adhesive strips activated, or insufficient nailing. You probe the lifted section gently with your screwdriver handle. 2 of the cap shingles move when probed, indicating they are not firmly seated. This is a wind vulnerability and a potential water entry point at the ridge. You photograph it and note it. The roof penetrations are the highest risk areas for leaks on any roof because they are the points where the continuous shingle field is interrupted and must be sealed by flashing. The penetrations on this roof include 2 plumbing vent stacks, 1 furnace exhaust vent, 2 bathroom exhaust vent caps, and the chimney for the gas fireplace. You examine each penetration. The plumbing vent stacks are flashed with pipe boot flashings, which are rubber or neoprene collars that seal around the circular pipe and are nailed to the roof deck beneath the shingles. The pipe boots on both vent stacks are correctly installed and appear sound. The furnace exhaust vent is a concentric vent pipe with 2 pipes inside each other. The inner carrying exhaust gases out and the outer drawing combustion air in, and it is flashed with a metal flashing and sealed with roofing sealant. The sealant on the furnace exhaust is present and uncracked, but the flashing itself is installed tight against the vent pipe with no clearance for thermal movement. Metal and PVC expand and contract at different rates with temperature change, and a flashing installed tight against a PVC exhaust vent will develop gaps at the sealant joint as the materials cycle through seasonal temperature ranges. You photograph this and note it as a concern that should be corrected before the warranty period ends. The chimney flashing requires more attention. The chimney is a framed and sided structure, not a masonry chimney, serving as the exterior enclosure for a direct vent gas fireplace. Insert below. The flashing at the uphill side of the chimney, called the step flashing and counter flashing, is aluminum and appears correctly installed. However, at the downhill side, the saddle flashing or cricket, which is a small peaked structure that diverts water around the back of the chimney rather than allowing it to pool, is absent. A cricket or saddle is required by most building codes when a chimney or penetration is wider than 30 inches measured perpendicular to the roof slope, because without it, water pools behind the chimney during rain events and is forced under the flashing. This chimney is 34 inches wide. A cricket is required. There is no cricket. You photograph the absence of the cricket from 2 angles and note it as a code deficiency and a high priority finding. You descend from the roof and record your findings in the photo log. Total roof findings: 3 low nail locations, 2 unseated ridge cap shingles, 1 tight flashing at the furnace exhaust vent, and 1 absent chimney cricket. For a new roof on a house that has not yet been occupied, this is a meaningful list. None of the findings will cause immediate catastrophic failure. Some will cause problems within 5 to 10 years, if not corrected. The absent cricket in particular will cause problems within the first 5 years. You will note it as a high priority item in the report. Attic access is through a hatch in the ceiling of the upstairs hallway. You set up your step stool, open the hatch, and push the insulation bat that covers the interior of the hatch to one side. You put on your Tyvek coverall, which keeps insulation fibers off your skin and clothing, and your safety glasses, and you pull yourself up into the attic. The attic of a new house tells a significant story about the quality of the construction. Because the attic is invisible during the construction process to everyone except the framers and the insulation crew, and it is invisible to the buyer at purchase. It is not invisible to you. You spend a few minutes in every attic you access, and you have seen things in attics that the homeowners below were entirely unaware of, and that required immediate attention. Water damage, missing insulation, improperly vented bathroom fans, disconnected HVAC ducts, and structural members cut by tradespeople who needed to route something through a space that a structural member was occupying. The attic is a conventional rafter and ridge board framing, not engineered trusses, which is slightly unusual for new production construction, where trusses are the overwhelming norm. Rafter framing gives a cleaner attic space, but requires more skilled framing labor. You examine the framing. The rafters are 2 by 6 lumber at 16 inches on center, which is the standard spacing. You check the ridge board connection at several locations. The rafters should be toe-nailed to the ridge board on both sides, and the connection should be tight with no gaps. At 2 locations on the left side of the ridge, you find rafter-to-ridge connections where the toenails have missed the ridge board and driven through into open space, leaving the connection with only 1 or 2 effective fasteners instead of 3 or 4. This is a framing deficiency that a qualified framing contractor should address before the warranty period ends. You photograph both locations. You examine the collar ties. Collar ties are horizontal members connecting opposing rafters in the upper third of the attic, providing resistance to the outward thrust that roof loads would otherwise impose on the exterior walls. Your building code requires collar ties at every 3rd rafter pair at maximum. You count the collar ties. They are present at approximately every 4th rafter pair, which is slightly below the code-required frequency. This is a minor structural deficiency, and you note it. The insulation is blown fiberglass, uniformly distributed across the attic floor at a depth that you measure by probing with your measuring tape. Approximately 11 inches throughout, with some areas near the eaves at 8 to 9 inches. 11 inches of blown fiberglass provides an R value of approximately R38, which meets the current energy code requirement for this climate zone. The thin areas near the eaves are concerning, however. The eave areas are the locations where insulation depth is most critical because they are also the areas where ventilation baffles must be maintained to keep the soffit vents open. You look toward the eave ends. You find that in approximately 40% of the rafter bays, no ventilation baffles have been installed, meaning the insulation has been blown directly against the underside of the roof, sheathing at the eaves, blocking the airflow from the soffit vents. Attic ventilation is a two-part system. Air enters through soffit vents at the eave, travels up through the rafter bays, and exits through ridge vents or upper gable vents, creating a continuous flow of outside air through the attic that removes moisture and prevents heat buildup. When the soffit vents are blocked by insulation, this airflow is interrupted. In winter, warm, moist air from the living space below condenses on the cold roof sheathing, causing moisture damage and potentially mold. In summer, the attic overheats, which reduces shingle life and increases cooling loads. The solution is ventilation baffles, also called rafter baffles or insulation stops, which are cardboard or plastic channels stapled to the underside of the roof, sheathing in each rafter bay before insulation is installed. They maintain a clear air channel from the soffit vent to the open attic space, regardless of insulation depth. Approximately 40% of the rafter bays in this attic are missing them. This is a significant deficiency. You examine the bathroom exhaust fan venting. Building code requires that bathroom exhaust fans duct to the exterior of the house, not into the attic, because discharging warm, moist bathroom air into the attic creates ideal conditions for mold growth in the attic insulation. And on the roof sheathing, you locate the flex ducts serving the two upstairs bathrooms. The master bathroom exhaust duct runs correctly to a roof cap, verified when you were on the roof. The hall bathroom exhaust duct, however, terminates approximately 2 feet into the attic space at a connection that has simply been left unattached. The flex duct end hanging loose in the attic insulation, discharging bathroom air directly into the attic. This is both a code violation and an active moisture source. You photograph it. This is a high priority finding. You note one additional finding before exiting the attic. There is a 1-inch gap in the top plate of an interior wall visible below the attic insulation near the center of the house. The top plate is the horizontal framing member at the top of a wall, and gaps in the top plate are bypasses, pathways through which conditioned air from the house can escape into the attic, or unconditioned attic air can enter the house. They also allow sound, smoke, and in the worst cases, fire and combustion gases to travel between the living space and the attic. This bypass should be sealed with an expanding foam sealant or fire-rated caulk as part of air sealing work. You photograph it and note it. You exit the attic. You remove the Tyvek coverall and shake out your clothing. You tell the clients, who have been watching from the hallway below, what you found. Their expressions have shifted slightly from the expression of people arranging furniture to the expression of people hearing something unexpected. You explain that all of the attic findings are correctable. None of them are structural failures, and all of them are things that the builder should address under the warranty. This is accurate. You also explain that the absent chimney cricket on the roof is the most pressing finding you have documented so far, and that it should be corrected as a priority. They nod. You proceed to the exterior. You conduct the exterior inspection by walking the perimeter of the house in a clockwise direction, examining the foundation, the exterior walls, the windows, the doors, the grating, the drainage, and all exterior penetrations. You carry your moisture meter and your camera. The clients follow at a short distance. The foundation is poured concrete. You examine the exposed portion of the foundation above grade at each side of the house. Foundation walls on new construction should be free of cracks, and the vast majority of them are. Concrete shrinks as it cures, and while hairline shrinkage cracks are common, and generally benign cracks, wider than 1/8 of an inch, or cracks with vertical or horizontal displacement on one side relative to the other, indicate a structural concern. You examine the foundation at all 4 sides. On the rear left corner, you find a diagonal crack in the foundation wall approximately 14 inches long, with a width of approximately 1/16 of an inch at its widest point. The crack is a uniform width throughout its length, consistent with a shrinkage crack rather than a structural movement crack, and there is no displacement between the 2 sides. You photograph it and note it as a minor finding to be monitored, with the recommendation that it be sealed with an appropriate concrete sealer to prevent water infiltration and to allow future monitoring for any change in width or length. The exterior walls are clad in vinyl siding with a fiber cement trim package at the corners, windows, and eaves. Vinyl siding is evaluated for installation quality, particularly the nailing pattern, and the clearances for thermal expansion. Vinyl siding expands and contracts significantly with temperature change, and installation instructions from all manufacturers specify that the siding should be nailed through the center of the nailing slot, not at the end of the slot, so that the siding can slide freely as it expands and contracts. Siding nailed tightly at the edge of the slot, or worse, nailed through the face of the panel rather than through the slot, is locked in place and buckles when it heats up. You examine the left gable end, where you noted the waviness from the street. Close examination confirms that a section of approximately 8 courses of siding in the lower left portion of the gable is buckled into a wavy pattern. You insert a finger under the edge of one of the buckled courses. You can feel that the siding is tight against the corner trim piece with no clearance gap, which confirms that the siding was installed too tight to the adjacent trim, leaving no room for thermal expansion. This is an installation deficiency, not a manufacturing defect. You photograph the buckled section from 2 angles, including a close-up that shows the absence of the clearance gap, and note it in your findings. You examine the window installations. Windows in new construction are typically installed by a dedicated window crew that is separate from the framing crew, and the siding crew creating a coordination zone where mistakes can occur. The window is in the opening. The flashing must be integrated with the weather-resistant barrier behind the siding, and the siding must lap correctly over the trim. You examine the window flashing and trim at 4 windows on the front and sides of the house. At the large double window on the left side of the house, you find a flashing deficiency. The head flashing above the window, the horizontal piece of metal that diverts water from above the window outward over the trim, is present, but has not been integrated with the building wrap behind the siding. The building wrap is not lapped over the top of the head, flashing, which means water that runs behind the siding above the window can reach the top of the window opening and potentially infiltrate the wall cavity. You verify this with your moisture meter at the interior window sill of the same window. The moisture reading is 5%, which is within the dry range, and means there is no active moisture intrusion at this time. However, the flashing deficiency will allow moisture to reach this location, and in a wet season, it will eventually cause a moisture reading above the dry range. You photograph the flashing from inside and outside and note it as a deficiency requiring correction. You examine the grading around the foundation. Building code and standard practice require that the ground slope away from the house at a minimum of 6 inches of fall in the first 10 feet of horizontal distance from the foundation, directing surface water away from the foundation wall. Inadequate grade allows water to pool against the foundation, which can saturate the soil, generate hydrostatic pressure against the foundation wall, and eventually infiltrate the basement or crawl space. On the rear of the house, you find a low area adjacent to the foundation where the grade is actually slightly negative, meaning the ground slopes toward the house rather than away from it, in a section approximately 12 feet long. This low area appears to be where the soil has settled following backfilling during construction. You note it as a grading deficiency and recommend that the low area be regraded to restore positive drainage away from the foundation. You examine the caulking at all exterior penetrations, the hose bibs, the electrical service entrance, the gas meter, the air conditioning refrigerant line set, the dryer exhaust vent, and the exhaust vents at the foundation for the crawl space. All caulk applications should seal completely around the penetration without gaps or voids, and should be a paintable exterior grade siliconized acrylic or polyurethane sealant. The caulking at the dryer exhaust vent is incomplete, with an approximately 1-inch gap at the top of the vent penetration where the caulk did not reach, leaving an open pathway for water and insects to enter the wall cavity. You photograph it and note it. The caulking at all other penetrations is acceptable. The garage is a 2-car attached garage with a side entry door to the interior of the house. The garage inspection covers the garage structure, the garage door and opener, the fire separation between the garage and the living space, the floor, and the mechanical equipment, if any is located in the garage. You examine the fire separation wall and ceiling between the garage and the living space. Building code requires that the wall and ceiling separating an attached garage from the living area of the house be constructed of fire-resistant materials, typically 5/8 inch type X drywall on the garage side of the wall and ceiling. The purpose of this requirement is to provide a fire-resistive barrier that slows the spread of a fire starting in the garage to the living space, giving occupants time to escape. This requirement is one of the more important life safety elements in residential construction. You examine the drywall on the garage side of the party wall. The wall drywall appears to be regular 1/2-inch drywall rather than the required 5/8 type X. You probe the wall surface with your screwdriver. The board flexes under light pressure in a manner consistent with 1/2-inch drywall, and the thickness at an electrical box opening near the garage service door confirms a board thickness of approximately 1/2 inch. You note this as a code deficiency and a life safety concern. The drywall should be replaced with 5/8 type X drywall or an appropriate fire-rated alternative on the garage side. The door between the garage and the house interior is a hollow core interior door. This is incorrect. The door between an attached garage and the living space is required by code to be a solid wood or solid steel door or a 20-minute fire-rated door to provide the same fire resistance as the wall it is installed in. A hollow core door provides essentially no fire resistance. You note this as a code deficiency and a high priority life safety finding. A fire-rated door must be installed. You photograph the door, noting its hollow sound when knocked, and include the photograph in your findings log. You examine the garage floor for cracks. Garage floors are typically 4-inch concrete slabs, unreinforced or minimally reinforced. poured on compacted subgrade. Concrete shrinkage cracks are common and expected in garage floors. What you are looking for are control joints, the tooled or saw-cut grooves in the concrete that direct the inevitable shrinkage cracks to predetermined locations, so they occur in straight lines rather than random patterns. The garage floor has no visible control joints. The concrete has cracked in 3 locations, with the largest crack running diagonally across the floor from the left rear corner toward the center, approximately 8 feet long and 1/8 of an inch wide. This crack is larger than a typical shrinkage crack and may indicate either excessive shrinkage from too wet concrete mix or a subgrade settlement issue. You note it and recommend monitoring for any increase in width or vertical displacement. The absence of control joints is a workmanship deficiency. The garage door is a 2-panel steel sectional door with a belt drive opener. You operate the garage door through its full cycle using the wall button. It opens completely, reverses when you place a 2x4 flat on the floor in the path of the closing door, which tests the safety auto-reverse function and closes completely. The auto-reverse function is working correctly. The photo eye sensors at the bottom of the door tracks, which reverse the door if a beam between the 2 sensors is interrupted during closing, are present and properly aligned. You verify alignment by confirming that the door reverses immediately when you break the beam with your hand. Both safety features are functional. You examine the garage door, weather stripping. The bottom seal of the garage door has a gap of approximately 3/4 of an inch on the right side, where the seal does not contact the floor, which would allow water, pests, and cold air to enter under the door on the right side. This is a minor deficiency, correctable by shimming the track or replacing the bottom seal. You note it. The electrical system inspection covers the service entrance and meter, the main panel, the wiring visible in the attic and basement or crawl space, the receptacles, the switches, the light fixtures, and the electrical safety devices, including GFCI protection and AFCI protection. You are not a licensed electrician, and you do not perform load calculations or evaluate the electrical system's design. What you evaluate is the visible installed condition of the electrical system and its compliance with the safety standards that apply to a general visual inspection. The main panel is a 200 amp service, which is the standard for new residential construction and is adequate for this size and type of house. The panel is a commonly available residential panel brand located in the utility room adjacent to the garage. You open the panel cover and examine the interior. The panel interior is evaluated for the breaker types and their compatibility with the panel brand, the condition of the wiring, the labeling of the circuits, and the presence of any safety concerns, including double-tapped breakers, open knockouts, missing breakers, or evidence of overheating. You examine each of these. The breakers are single pole and double pole breakers of the brand compatible with this panel. All breakers appear to be the correct type for the panel. However, you note that the panel has 3 circuits with no breakers installed, leaving open slots in the panel bus that are covered by plastic filler covers rather than breakers. This is acceptable and is common in panels with room for future circuit additions. You note the open slots for informational purposes. Circuit labeling in a new construction panel is often poor, and this panel is not an exception. Of the 28 circuits in the panel, 12 are labeled with generic descriptions such as bedrooms or kitchen, without specifying which bedroom or which kitchen circuit. 2 circuits are labeled with abbreviations that are not self-explanatory. 4 circuits are unlabeled entirely. Proper circuit labeling is required by the National Electrical Code, NEC, and poor labeling is a nuisance in normal circumstances and a significant safety issue in an emergency. You note the labeling deficiency and recommend that the circuits be traced and accurately labeled. You find 1 double-tapped breaker in the panel. A double-tapped breaker is a breaker with 2 conductors connected to the same terminal, which is a code violation in most circumstances because the terminal is designed and rated for a single conductor. The forces applied to 2 conductors at a single terminal may not be uniform, leaving 1 conductor loose, which can arc and cause a fire. Double-tapped breakers also complicate circuit identification. The double-tapped breaker is on a 20-amp circuit, serving what is labeled kitchen small appliances. You photograph it and note it as a code deficiency requiring correction. You test the GFCI protected circuits. GFCI stands for Ground Fault Circuit Interrupter, and GFCI protection is required by code in all wet locations in a house. Bathrooms, the kitchen within 6 feet of a sink, the garage, the exterior, the basement, and any unfinished areas. The GFCI device monitors the current flowing out on the hot conductor and returning on the neutral conductor. If there is a difference of 5 milliamps or more, indicating that some current is flowing through a path other than the intended circuit, such as through a person who has touched a live conductor, the GFCI trips in approximately 30 milliseconds and interrupts the circuit. This trip time is fast enough to prevent electrocution in most circumstances. You use your 3-light circuit tester with GFCI test function on the receptacles in each required location. In the master bathroom, the GFCI protected receptacle trips correctly when tested and resets correctly. In the hall bathroom, the receptacle trips correctly. In the kitchen, you test the receptacles near the sink on both sides. The left side receptacle trips correctly, but the right side receptacle does not trip when the test button is pressed. You confirm the circuit is live by verifying that the tester's indicator lights show power at the receptacle. A live receptacle in a GFCI required location that does not respond to the test function is a deficiency. Either the GFCI protection is not functioning, or this receptacle is not on a GFCI protected circuit. You test the adjacent outlet and confirm the same result. You photograph the tester showing no GFCI response at the kitchen right side sink receptacles and note it as a high priority electrical finding. You also test for AFCI protection. FCI stands for arc fault circuit interrupter, and AFCI protection is required by the NEC in all sleeping rooms, living rooms, dining rooms, and family rooms of new construction. FCI breakers detect the electrical signature of arcing faults, which can cause fires in wiring hidden inside walls. In this panel, you verify that the circuits labeled as bedroom circuits are FCI type breakers by examining the breaker faces for the AFCI test button. 3 bedroom circuits are on AFCI breakers. The 4th bedroom circuit, the smallest bedroom which was configured as a bonus room, is on a standard breaker without AFCI protection. This is a code deficiency. The circuit should be upgraded to an AFCI breaker. You photograph the non-AFCI breaker and note it. The plumbing inspection covers the water supply system, the drain waste vent system, the water heater, and all plumbing fixtures. You turn on all faucets, flush all toilets, test all shut-off valves, and run water in multiple locations simultaneously to observe pressure performance and drainage rates. The water supply is public water, entering the house through a 1-inch copper main, which is appropriate for this size house. The main shut-off valve is a ball valve located adjacent to the pressure-reducing valve, PRV, in the utility room. You operate the main shutoff. It opens and closes smoothly with a quarter turn. You verify that the shutoff valve location is known to the clients and that they know how to operate it. This information is not in the inspection report, but is part of the walkthrough. Every homeowner should know where their main shutoff is and how to close it within 30 seconds of a plumbing emergency. You show them. The water pressure at the utility room hose bib is 64 pounds per square inch. Measured with a pressure gauge, you attach to the hose bib thread. The acceptable range for residential water pressure is 40 to 80 pounds per square inch. Above 80 pounds per square inch, the elevated pressure stresses supply fittings, appliance connections, and fixture valves, reducing their service life and increasing the risk of leaks. At 64 pounds per square inch, the pressure is within range and the PRV is performing correctly. You turn on all fixtures simultaneously to test pressure performance. Master bath shower, hall bath shower, kitchen sink, and a hose bib. Pressure at all locations remains adequate during simultaneous operation, meaning the supply system is adequately sized. You then turn them off one at a time and observe the drainage. The master bath shower drains quickly and completely. The hall bath shower drains adequately. The kitchen sink drains quickly. You fill the kitchen sink to the rim and release the stopper. The sink drains, but gurgles noticeably as the water level drops, particularly in the final quarter of drainage. Gurgling in a drain indicates inadequate venting. The drain vent allows air to enter behind the flowing water, preventing the formation of a vacuum that would cause the trap to empty and allow sewer gas into the house. A gurgling drain indicates that the vent is insufficient, undersized, or improperly installed, and that the drain is pulling air through the trap rather than through the vent. Sewer gas, which includes hydrogen sulfide and methane, is both noxious and potentially flammable. A drain that regularly empties its trap allows it into the house. You note the gurgling as a venting deficiency and flag it for investigation by a licensed plumber. You test the toilets. You flush each toilet and observe the bowl refill, the tank refill, and the final resting water level in the bowl. The master bath toilet flushes correctly and refills correctly. The hall bath toilet flushes, refills, and then continues to run. You lift the tank lid and observe. The fill valve is continuing to run water into the bowl via the overflow tube, which means the tank water level is set too high, above the critical level marking on the overflow tube. This is a running toilet that will waste water continuously until adjusted. It is a minor deficiency, correctable by adjusting the fill valve float. But it is worth noting because a running toilet can add significantly to a water bill if not corrected. And because in new construction, it represents a fixture that was not properly adjusted before turnover. You note it. You test the hall bathroom shower valve. This is a pressure balancing valve, which is a code-required safety device that maintains a constant ratio between hot and cold water, even when pressure in one supply changes suddenly, such as when a toilet is flushed. Without a pressure balancing valve, flushing the toilet while someone is showering causes a surge of hot water as the cold pressure drops, potentially scalding the bather. You test the pressure balancing performance by flushing the hall bath toilet while the shower is running. The shower temperature does not change perceptibly. The pressure balancing valve is functioning correctly. You examine the water heater in the utility room. The water heater is a 50-gallon natural gas unit, the appropriate capacity for a 4-bedroom, 2.5 bath home. You check the T&P relief valve, which is the temperature and pressure relief valve that prevents the water heater tank from becoming a pressure vessel if the thermostat fails and the water overheats. The T&P relief valve has a discharge pipe that should extend to within 6 inches of the floor or to the exterior of the house, so that if the valve releases, The discharge of scalding water is directed safely away from occupants. On this water heater, the T and P discharge pipe terminates 8 inches from the wall in the utility room, pointing horizontally at approximately knee height toward the center of the room. If the T and P valve released, the scalding discharge would spray directly across the room at knee level. The discharge pipe must be extended to within 6 inches of the floor. You note this as a safety deficiency. You also note that the gas supply line to the water heater is a flexible corrugated stainless steel connector, CSSD, which is the standard for appliance connections. The connector is properly installed with the appropriate fittings and is not kinked. The draft hood on the water heater connects to a B-vent that exits through the roof. You verify that the B-vent connections in the utility room are secure and that the draft hood is properly seated. All are correct. The HVAC inspection covers the heating, ventilation, and air conditioning systems. The furnace, the air conditioning unit, the ductwork, the thermostat, and the air filtration. You operate both the heating and cooling systems and verify their function. Examine accessible ductwork for leaks and installation defects, and check the combustion air supply and exhaust venting for the furnace. The furnace is a 96% efficiency natural gas condensing furnace located in the utility room. A 96% efficiency furnace extracts so much heat from the combustion gases that the exhaust temperature drops below the dew point, causing the moisture in the combustion gases to condense into liquid water, which is why it is called a condensing furnace. The condensate is collected in a drain pan and piped to a floor drain or a condensate pump. Because the exhaust gases are cool and moist rather than hot and dry, a condensing furnace cannot use a conventional metal flue. Instead, it vents through PVC pipes, typically a 2-inch or 3-inch pipe that exits through the sidewall of the house rather than through the roof. You verified the exterior PVC vent terminations during your exterior inspection. They were correctly installed with appropriate screening to prevent pest entry. You set the thermostat to heat mode at a temperature 10 degrees above the current indoor temperature and observe the furnace. The furnace inducer motor starts, drawing air through the combustion chamber. After approximately 30 seconds, the igniter glows, the gas valve opens, and the burner lights. The burner flame is stable, and the characteristic blue color with small yellow tips, consistent with proper combustion. The furnace runs through its startup sequence, and the blower motor engages approximately 90 seconds after ignition, delivering warm air to the distribution system. You hold your hand at the return air register. There is a strong negative pressure drawing room air into the return, indicating that the blower is operating at an appropriate airflow rate. You check the supply registers in each room while the furnace is running, verifying that air is being delivered at each location. In the fourth bedroom, the one configured as a bonus room, you find that the supply register is delivering noticeably less airflow than the registers in the other bedrooms. You examine the register. It is open and unobstructed. You remove the register grill and look into the duct with your flashlight. The duct boot, the rectangular metal fitting that connects the round flex duct to the rectangular floor register opening, is installed and intact. But when you trace the flex duct back toward the trunk line, you find a kink in the flex duct approximately 2 feet from the boot, where the duct makes an abrupt bend. A kinked flex duct has a dramatically reduced airflow capacity, sometimes by 60% or more, depending on the severity of the kink. Flex ductwork should be installed with gradual bends, supported to prevent sagging and kinking, and with a minimum bend radius of 1 times the duct diameter. This kink has an effective radius of approximately 2 inches in a 6-inch duct, far below the minimum. You photograph the kink and note it as a deficiency, causing reduced airflow to the fourth bedroom. You examine the return air system. The return air system is the network of ducts and grills that draws room air back to the furnace for reconditioning, and it must be sized to handle the same volume of air that the blower is supplying. Undersized return systems cause the furnace to operate at elevated static pressure, which reduces airflow, stresses the blower motor, and can cause the furnace to overheat on its high limit switch. You verify that return air grills are present in the correct locations, in the hallway and in each of the 4 bedrooms. There are return air grills in the hallway and in 3 bedrooms. The 4th bedroom, the bonus room, has no return air grill, a room with a supply register, but no return air path cannot equalize its pressure with the rest of the house when the HVAC system is running, which causes the door to drift open or shut, causes reduced airflow to the room, and can create pressure differentials that drive air infiltration through wall and ceiling penetrations. This is related to the kinked duct, but is a separate deficiency. You note both. You switch the thermostat to cooling mode and observe the air conditioning system. The condensing unit outside starts and runs. You verify that cold air is being delivered at the supply registers. You hold a thermometer at the return air grill and at a supply register simultaneously. The supply air temperature is 58 degrees Fahrenheit, and the return air temperature is 74 degrees Fahrenheit, a split of 16 degrees. The standard for a correctly functioning central air conditioning system is a temperature split of 14 to 22 degrees Fahrenheit between the supply and return air. 16 degrees is within the acceptable range, indicating the system is functioning correctly. You note this as a satisfactory finding. You examine the condensing unit on the exterior pad. The unit is level on its concrete pad. the refrigerant lines are insulated. The disconnect box adjacent to the unit is correctly installed. You note that the area around the condensing unit has been planted with ornamental grasses that are currently about 1 foot high, but are a species that will grow to approximately 4 feet, which would eventually restrict airflow to the condenser. You mention this to the clients as a maintenance note. Keep vegetation trimmed back at least 2 feet from the condenser on all sides. This house has a partial basement under the utility room and a crawl space under the remainder of the first floor. You enter the basement first. The basement is an unfinished utility space approximately 12 by 20 feet, containing the water heater, the furnace, the main electrical panel, and the condensate drain. You have already inspected the mechanical equipment. Now you examine the basement structure. The basement walls are poured concrete with a waterproofing membrane applied on the exterior during construction. Interior basement walls should be examined for efflorescence, which is the white mineral deposit left when water passes through concrete and evaporates on the interior surface, carrying dissolved minerals with it. Efflorescence indicates that water is moving through the wall, even if it is not actively leaking. You find a 4-inch band of light efflorescence along the base of the rear basement wall. The concrete is not damp when tested with your moisture meter at the efflorescence location, and the floor shows no signs of past water intrusion. The efflorescence is likely from the initial curing period of the concrete, when moisture movement through the wall is expected, and may not indicate an ongoing problem. However, combined with the negative grade you found at the rear of the house during your exterior inspection, the efflorescence is worth noting as a finding to monitor. If the grade is corrected and the efflorescence continues or worsens, further investigation is warranted. You note both the efflorescence and its connection to the grading finding. You access the crawl space through a hatch in the utility room floor. The crawl space is approximately 18 inches high at its lowest point, adequate for access on your hands and knees, but not comfortable for extended work. You put your knee pads back on and your Tyvek coverall and enter. The crawl space has a 6 mil polyethylene vapor barrier on the ground, which is the standard practice for controlling ground moisture in a crawl space. You examine the vapor barrier. It covers the ground completely, laps up the foundation walls by approximately 6 inches, and the seams between adjacent sheets are overlapped by at least 12 inches. This is a correctly installed vapor barrier. In new construction, vapor barriers are sometimes installed correctly and sometimes installed carelessly. This one is correct. You examine the floor framing visible above you in the crawl space. The framing consists of engineered I-joists, a manufactured product with a wood top and bottom flange connected by a thin oriented strand board web, spanning from the foundation walls to a center beam. I-joists are the standard product for floor framing in new construction because they are dimensionally stable, resist warping and shrinkage, and allow longer spans than dimensional lumber of the same depth. You examine the I-joists for any damage, cuts through the web, notches in the flanges, or overdriven nails that have penetrated too deep into the flange. You find one I-joist with a 2-inch diameter hole cut through the lower flange, apparently to route a small pipe. The lower flange of an I-joist is the tension member of the beam and cannot be cut or notched without significantly reducing its load capacity. This is a structural deficiency that requires evaluation and likely repair by a qualified structural engineer or the framing contractor. You photograph it carefully from 2 angles and note it as a high priority finding. You also note that in the crawl space, the flex duct serving the hall bathroom exhaust fan is correctly routed through the floor framing and exits through the exterior foundation wall as observed during the exterior inspection. This is the bathroom fan that is properly vented, as contrasted with the unvented attic bathroom fan described earlier. You note the discrepancy between the 2 bathrooms for clarity in the report. One bathroom fan is correctly vented to exterior. One is venting to the attic. The report should make this distinction clear so the builder understands exactly which bathroom needs attention. You conduct the interior inspection room by room, beginning on the 1st floor. The interior inspection evaluates the walls, ceilings, floors, windows, doors, and built-in components in each room. You are looking for evidence of moisture, structural movement, workmanship deficiencies, and anything that affects the habitability or safety of the space. The entry foyer is a 2-story volume with a staircase visible to the right. The floors are hardwood, which appears to be an engineered hardwood product with a factory-applied finish. You examine the hardwood floor throughout the 1st floor. The floor is generally level and well installed. At the transition between the entry foyer and the living room, you observe that 3 boards have gaps between them that are wider than typical for an engineered hardwood installation. You measure one gap, approximately 3/16 of an inch, which is wider than the 1/8 inch maximum typically specified for engineered hardwood. The gapping can indicate that the floor was installed before the house was climate conditioned and the boards dried out after installation, or that the boards were not adequately acclimated before installation. Gapping of this magnitude may close partially as the house is occupied and humidity normalizes, or it may remain. You photograph the gapping and note it as a cosmetic deficiency that may be a workmanship issue related to installation conditions or acclimation procedures. In the living room, you probe the drywall at the ceiling perimeter with your flashlight at a low angle, which is a technique called oblique lighting or raking light, in which the light source is held nearly parallel to the surface. Raking light reveals surface irregularities that are invisible under normal overhead lighting. Waviness in the drywall plane, tool marks, uneven taping joints, and popped fasteners. You find 3 nail pops on the living room ceiling. Locations where nails or screws in the drywall have moved slightly and created a small raised bump on the drywall surface. Nail pops are common in new construction and result from the framing lumber drying and shrinking after installation, causing the fasteners to work loose slightly. They are a cosmetic deficiency in most cases and are expected to be addressed under the builder's warranty. You note them without alarm. In the kitchen, you examine the cabinetry, the countertops, the appliances, and the fixtures. The kitchen cabinets are a semi-custom production cabinet line, correctly installed and plumb in the vertical and level at the base. You open each cabinet door and drawer. All operate smoothly with the exception of one lower cabinet door on the right side of the sink base, which does not close fully, stopping approximately 3/8 of an inch from the face frame. The door hinge is an adjustable European-style concealed hinge, and the clearance is achievable by adjusting the hinge. You demonstrate the adjustment to the clients and note it as a minor deficiency. You examine the kitchen countertop at the sink. The countertop is quartz, which is an engineered stone product that is durable and low maintenance. The sink cutout in the countertop has a slight chip at the underside of the cutout, approximately 3/4 of an inch long, that is visible when you look under the rim. The chip is in an area normally covered by the sink rim and is not visible during normal use, but it is a workmanship deficiency that you note for completeness. You examine the kitchen backsplash tile. The tile is a 4x12 rectangular subway tile in a stacked pattern. Grout joints are consistent in width and fully filled. However, the caulk joint at the countertop to backsplash interface, which should be a flexible caulk rather than rigid grout to accommodate the differential movement between the countertop and the wall, is filled with grout rather than caulk. Grout at this joint will crack as the countertop and the wall move relative to each other with normal house settlement and temperature cycling. This is a standard installation error that occurs frequently in new construction and is easily corrected by removing the rigid grout and replacing it with a color-matched siliconized caulk. You note it. You run the dishwasher through a brief cycle to verify it operates. The dishwasher starts, fills, and runs. You stop the cycle after 2 minutes and verify that water is not leaking at the connections under the sink. The drain hose connection is dry and secure. You note the dishwasher operation as satisfactory. You also verify the garbage disposal. It operates, and the reset button functions when tested. You note the disposal as satisfactory. You move to the second floor. The staircase is solid with no movement at the treads or risers. The handrail is correctly installed, and returns to the wall at both the top and bottom, which prevents a loose object from catching on the end of a freestanding handrail and causing a fall. The balusters, the vertical members between the handrail and the treads, are at appropriate spacing. You verify that a 4-inch sphere cannot pass between any two adjacent balusters, which is the standard intended to prevent a child's head from becoming trapped. All baluster spacings are within the 4-inch limit. The staircase is correctly built, and you note it as satisfactory. The master bedroom is large, with a tray ceiling and a walk-in closet. You examine the ceiling with raking light. The tray ceiling has a more complex geometry than a flat ceiling, and the drywall finishing at the transitions between the flat center and the angled returns must be precise to look correct. The transitions on this tray ceiling show two locations where the drywall tape at the inside corner has not been properly feathered into the surrounding surface, leaving a visible raised line. This is a taping deficiency that should be sanded and refinished. It is cosmetic. You note it. The walk-in closet has a clothes rod and shelf system installed by a third-party shelving contractor. You examine the shelf mounting. The shelves are mounted to drywall anchors rather than to studs or to a continuous mounting rail, and one shelf bracket is visibly pulling away from the wall at its upper anchor. Point the anchor, having partially extracted from the drywall under the weight of the shelf. Drywall anchors for heavy shelving in closets are inadequate. The shelving should be remounted with fasteners into wall studs. You note it. The master bathroom has a double vanity, a soaking tub, a separate shower, and a toilet room. You have already tested the toilet and the pressure balancing valve on the shower. You now examine the tile work in the shower and tub surround. The shower has large format porcelain tile on the walls and a mosaic tile floor. Large format tile requires a very flat substrate to prevent hollow spots under the tile, which occur when the tile is not fully bedded in the mortar and leave areas of the tile unsupported. A hollow spot does not prevent the tile from functioning normally in the short term, but under repeated foot traffic and thermal cycling, hollow spotted tiles eventually crack. You test the shower floor tiles by tapping them with your knuckle, listening for the dull thud of an unsupported tile versus the solid sound of a fully bedded one. On the shower floor, you find 4 mosaic tile sections that sound hollow when tapped. You note them as hollow tile deficiencies and recommend that a tile installer evaluate and regrout or rebed the hollow sections. You examine the grout joints in the shower for completeness and for cracking. The grout joints are filled and uniform. At the inside corner transitions between the wall tiles, however, you find that the joints have been filled with the same rigid grout as the field joints, rather than with a flexible caulk. This is the same issue you noted in the kitchen, and it is a standard installation error. that occurs throughout the industry with such frequency that the Tile Council of North America's installation standards specifically address it. Movement joints in all inside corners must be caulked with a sealant not grouted. The consequence of grouting inside corners in a shower is predictable. As the structure moves, the rigid grout at the corners cracks, creating pathways for water to penetrate behind the tile. Water behind shower tile is one of the most common causes of concealed moisture damage in residential construction. You photograph the grouted inside corners in the shower and note them as a deficiency requiring correction. In the hall bathroom, you find a similar condition. Grouted inside corners in the tub surround. You note it. You also note that the caulk at the tub-to-floor transition, the joint between the bottom of the tub and the tile floor, is already showing a small gap of approximately 1/16 of an inch at the left side, approximately 6 inches from the corner. Gaps in tub-to-floor caulk allow water to penetrate under the tub and into the subfloor. On a new house, this gap represents either a settling of the tub or an inadequate original caulk application. You note it as a deficiency requiring immediate recaulking. The fourth bedroom, the bonus room, has wall-to-wall carpet. You examine the carpet installation. The carpet is stretched correctly, and the seam near the closet door, where 2 pieces of carpet meet, is nearly invisible. The carpet is correctly transitioned to the hardwood flooring in the hallway with a metal transition strip. You find no deficiencies in the carpet installation. You do note, for the client's information, that this room's insufficient HVAC airflow due to the kinked duct means it will likely be the warmest room in the house in summer and the coolest in winter until the duct is corrected. You conduct a systematic check of all windows and exterior doors, and you verify the operation and installation of all required safety devices, including smoke detectors, carbon monoxide detectors, and bathroom ventilation. Every window in the house is operated, raised, lowered, locked, and unlocked. The windows are double-hung vinyl units, a standard product for this price range. All windows operate smoothly with the exception of one. The master bedroom front window does not lock completely. The 2 sashes meet correctly, but the latch mechanism does not fully engage. You can feel the sash shift slightly when you apply lateral pressure with the window locked. The latch itself appears to be a manufacturing defect rather than an installation issue. You note it as a deficiency requiring replacement of the latch hardware. You verify that the windows in sleeping rooms meet the egress requirements of the building code. Sleeping room windows must have an openable area of at least 5.7 square feet to allow occupants to escape in a fire emergency, with a minimum opening width of 20 inches and a minimum opening height of 24 inches, and the sill height must be no more than 44 inches from the floor. You measure the egress opening on the windows in each bedroom. 3 bedrooms have windows that meet all egress requirements. In the 4th bedroom, the bonus room, the window provides a net open area of 5.3 square feet, slightly below the 5.7 square foot minimum. This is a code deficiency and a life safety finding. The window must be replaced with a compliant unit, or the rough opening must be enlarged to accept a larger window. You test all exterior doors for operation, whether stripping and threshold seals. The front door, the rear sliding glass door, and the garage service door all operate correctly. The threshold seal on the front door is in full contact with the door bottom across the full width, preventing drafts and water infiltration. The rear sliding glass door glides smoothly on its track. You lock and unlock each door and verify that the latches engage correctly. The door from the house to the garage, which you have already noted has the wrong fire rating, also has an incorrect door swing. It swings into the garage rather than into the house. The building code requires that the door between a garage and a living space swing into the house or be a self-closing door, because a door that swings into the garage could be blocked by a vehicle or other object, preventing escape in a fire emergency. This door swings into the garage and does not have a self-closing mechanism. This compounds the fire safety concerns with this door. It is hollow core instead of fire rated, and it swings the wrong direction. Both deficiencies must be corrected. You test the smoke detectors. The house has 7 smoke detectors, 1 in each bedroom, 1 in the hallway outside the bedrooms, and 1 on the first floor near the kitchen. The detectors are hardwired to the electrical system with battery backup, which is the code-required installation method for new construction. You press the test button on each detector. 6 detectors produce the required loud, pulsing alarm. The 7th detector, in bedroom 3, produces a tone that stops after approximately 2 seconds, which is not the sustained alarm required for a functioning unit. You note the defective smoke detector as a life safety finding. A new smoke detector must be installed in bedroom 3 before occupancy. You verify carbon monoxide detector placement. The building code requires carbon monoxide detectors outside each sleeping area and on each level of the house. This house has 1 carbon monoxide detector in the upstairs hallway, outside the sleeping areas. There is no carbon monoxide detector on the main level or in the basement utility room adjacent to the gas-fired water heater and furnace. The code requires detectors on each level. The main floor and basement level are unprotected. You note this as a life safety finding requiring installation of additional carbon monoxide detectors. You verify the bathroom exhaust fans by turning each one on and holding a tissue at the grill. The master bath fan draws the tissue to the grill, indicating adequate suction. The hall bath fan draws the tissue to the grill. Both fans are operating. However, you already noted during the attic inspection that the hall bath exhaust is vented into the attic rather than to the exterior. The fan works. It is simply discharging to the wrong location. This remains a high priority finding. The physical inspection is now largely complete. Before you leave the property, you conduct your final walkthrough notes and photograph any items you have not yet photographed. Then you sit with the clients for approximately 15 minutes at the kitchen table for what you call the summary conversation. The summary conversation is not the report. The report will be written tonight, organized, illustrated with photographs, and delivered in the morning. The summary conversation is the verbal context for what the clients have watched and heard over the past 3 hours. You tell them, this house has a meaningful list of deficiencies, as you have seen, and some of them are significant. You will organize the findings in the report into 3 categories: safety items, deficiencies requiring repair, and maintenance recommendations. Safety items are findings that represent a hazard to occupants. From today's inspection, the safety items are the hollow core garage to living space door that must be replaced with a fire-rated door, the incorrect garage to living space drywall that must be replaced with fire-rated board, the incorrect garage door, swing the non-functional smoke detector in bedroom 3, the missing carbon monoxide detector on the main level, and basement, the kitchen GFCI receptacle that is not providing GFCI protection, and the T and P valve discharge pipe on the water heater that is not correctly terminated. These items are non-negotiable from a safety standpoint. They must be corrected regardless of any other negotiation outcome. Deficiencies requiring repair are findings that are not immediate safety hazards, but that represent code violations, significant workmanship defects, or conditions that will lead to damage or deterioration if not corrected. These include the absent chimney cricket, which will cause water infiltration at the chimney base within several years, the disconnected bathroom exhaust fan duct in the attic, which is venting moisture into the attic, the blocked soffit vent, rafter bays, without ventilation, baffles the missing AFCI breaker on the 4th bedroom, circuit the double-tapped breaker in the panel, the low-nailed shingles, and unseated ridge cap, the window flashing deficiency, the head flashing integration, failure at the left side window, the negative grading at the rear of the house, the I-joist lower flange cut in the crawl space, the kinked HVAC flex, duct the missing return air grill in the 4th bedroom, the running toilet, the gurgling kitchen drain the rafter to ridge connection, deficiencies, the missing collar ties, and the egress window deficiency in the 4th bedroom. The maintenance recommendations are observations about conditions that require monitoring or future action, but are not current code violations or immediate repair items. These include the foundation shrinkage crack and the associated efflorescence, the nail pops on the living room ceiling, the hardwood floor gapping, and the vinyl siding waviness on the gable end. You explain to the clients that the length of the list does not mean the house is unusually deficient for new construction. It means the house has been inspected carefully. Most of these findings are correctable by the builder under the warranty, and the builder's 1-year warranty is a legal obligation, not a suggestion. The clients should present the report to the builder and request correction of all findings before closing, or negotiate a price adjustment sufficient to cover the corrective work. You recommend that they consult with their real estate attorney about the appropriate approach for this transaction. The clients have several questions. You answer them. Their most pressing question is whether the house is safe to occupy. You tell them the house can be made safe with the correction of the safety items, several of which are simple and inexpensive. The hollow core fire door and the incorrect drywall are the most consequential safety items and the most costly to correct, but they are straightforward repairs. Before occupancy, at minimum, a fire-rated door should be installed between the garage and the house. The smoke detector in bedroom 3 should be replaced, and carbon monoxide detectors should be installed on all levels. The other safety items should be corrected as soon as possible after occupancy begins. You give the clients your business card and remind them that you are available by phone or email to clarify anything in the report once they have read it. You pack your equipment. You thank them for attending the inspection, which they should always do. They thank you. You leave. You write the inspection report at your home office desk. The report will be approximately 35 to 40 pages when complete, including the photographs and the narrative descriptions of each finding. You use inspection report software that provides a structured format into which you enter findings categorized by system, with embedded photograph slots that pull from your camera. Upload. The software generates a formatted document in PDF format that is uploaded to a secure portal, and the link emailed to the client. The ASHI standards of practice specify what a home inspection report must include: a description of each component inspected, a statement of the condition of each component, and a description of any deficiency found that, in the professional judgment of the inspector, warrants further evaluation or repair. The standards also specify what the report must not include: guarantees or warranties of any kind, statements about the cost of repairs, and opinions that are outside the scope of a general visual inspection. You do not estimate repair costs in your reports because cost estimates require knowing the specific extent of damage, which you cannot determine from a visual inspection, and because costs vary by contractor and market conditions. What you do provide is a clear description of each deficiency and a recommendation for the type of professional who should evaluate or repair it. The report introduction includes the limitations of the inspection, which are important for the client to understand. A home inspection is a visual examination of accessible areas of the home at a specific point in time. It does not include demolition or intrusive investigation, moving of furniture, stored items, or installed floor coverings, inspection of concealed areas such as within walls, beneath concrete slabs, or underground. Testing for mold, radon, asbestos, lead paint, water quality, or other environmental hazards, except where specifically contracted evaluation of swimming pools, septic systems, or well systems, except where contracted engineering analysis of structural components or prediction of future performance. Every item identified in the report was observed by visual inspection at the time of the inspection. Things behind walls are not the inspector's responsibility to find. Things behind walls that become apparent during future renovation are not things the inspection failed to find. They are things the inspection could not reach. You write the findings for the roof first. The 3 low nail locations, the 2 unseated ridge cap shingles, the tight flashing at the furnace exhaust, and the absent chimney cricket. For the chimney cricket, you write: the chimney at the left rear slope measures 34 inches in width, perpendicular to the roof slope. A cricket or saddle diverter is required by the International Residential Code at all chimneys or penetrations wider than 30 inches to divert water away from the uphill side of the chimney. No cricket is present. Water will pool behind the chimney during rain events and is likely to penetrate the chimney-to-roof flashing interface over time. Recommend installation of a properly flashed chimney cricket by a qualified roofing contractor prior to closing. You write the report section by section, following the same systematic order as the inspection. Roof, attic, exterior, garage, electrical, plumbing, HVAC, foundation and crawl space, interior first floor, interior second floor, windows and doors, and safety devices. For each finding, you write a description of the condition, a description of why it is deficient, and a recommendation for corrective action. The recommendation always specifies the type of professional appropriate for the repair: roofing contractor, licensed electrician, licensed plumber, HVAC technician, structural engineer, tile installer, or general contractor. You do not write "fix this" in a vacuum. You write who should fix it and what the fixing should entail. Photograph selection is part of the report writing process. Your camera contains 218 photographs from today's inspection. Not all of them will go into the report. Many are reference photographs taken to assist your own memory during report writing, rather than photographs that illustrate a specific deficiency. You select the most diagnostic photograph for each finding, the one that most clearly shows the deficiency to a reader who was not present, and embed it in the relevant section of the report. For some findings, you use 2 photographs, a wide shot showing the context and location, and a close-up showing the specific deficiency. The photographs are captioned. Caption text describes what the photograph shows and where it was taken, because a close-up photograph without context does not tell the reader where the deficiency is in the house. You complete the report at 11:15 in the evening. The finished document is 41 pages, contains 73 photographs, and lists 67 findings across all categories, 7 safety items, 42 deficiencies requiring repair, and 18 maintenance recommendations. You review the report once from beginning to end before uploading it, verifying that each finding is clearly described. Each photograph is correctly placed and captioned, and the report language is neutral and professional throughout. Neutral and professional means not alarmist, not dismissive, and not editorial. The report does not say this is a poorly built house. It says these are the things that are wrong with it. The client will draw their own conclusions. The inspection report is delivered by 8 in the morning. The clients read it and respond that afternoon. Their response is not unusual for buyers who have received a thorough inspection report on a new construction home. They are surprised by the length of the list, reassured by your explanation that the findings are largely correctable, and uncertain about how to proceed. New construction inspections occupy a particular position in the home inspection world because of the common assumption that new means correct. This assumption is understandable and incorrect in roughly the same proportion across the industry. Production home builders work with large subcontractor networks where the quality of any given trade crew varies considerably. The framing crew that built this house with the raftered ridge nailing misses may be excellent on other days with other projects, and was simply rushing on the day they worked this house. The insulation crew that missed the ventilation baffles may have been working quickly at the end of a long day. The HVAC crew that kinked the flex duct may have been working around other trades in a cramped space. None of these explanations excuse the deficiencies, but they explain why new construction deficiency lists are often longer than buyers expect. The builder's warranty is the mechanism for addressing new construction deficiencies. The standard warranty for production homes in the United States covers workmanship defects for 1 year, mechanical systems, including HVAC, plumbing, and electrical for 2 years, and structural defects for 10 years. The definitions of what constitutes a covered defect vary by builder, and some warranty language is written in ways that limit the builder's obligation more than it might appear. Reading the warranty carefully before signing the purchase contract is advisable. though most buyers do not do this. Your report gives the client's documentation of the deficiencies found at the time of inspection. Presenting this report to the builder is the appropriate initial step. Builders respond to inspection reports with varying degrees of cooperation. Some builders have a structured warranty response process and address inspection findings promptly. Others require repeated follow-up and escalation. A few deny findings that are clearly documented in the report and photographs, which is an approach that tends to result in regulatory complaints and occasionally litigation. The clients in today's case will be guided through this process by their real estate agent and attorney, who have more experience with this specific builder's warranty practices than you do. Your role is complete when the report is delivered. What happens after is between the clients, the builder, and their advisors. You are occasionally asked by clients whether they should walk away from a purchase based on the inspection findings. You do not answer this question because it is not a question an inspector can answer. The decision to purchase a home involves financial considerations, personal circumstances, market conditions, and risk tolerance that are not within the scope of a home inspection. What you can say and what you told these clients in the summary conversation is that the deficiencies found in this home are correctable. None of them indicate that the house is structurally unsound or functionally uninhabitable. The safety items must be corrected. The deficiency items should be corrected, whether the builder will correct them before closing, and whether the price and terms of the transaction reflect the cost and effort of correction, are questions for the negotiation that follows, not for you. You are also asked, occasionally, whether you could have missed something. The answer is yes, and you say so. A home inspection is a visual examination of accessible areas at a point in time. Things behind finished walls, beneath concrete slabs, or inside sealed mechanical components are not visible. Problems that have not yet manifested visibly will not be found. Deficiencies that appeared after you left will not be in the report. You apply professional judgment to what you observe. But professional judgment applied to a visual examination of a completed house is not the same as an X-ray, and the report should not be treated as a guarantee that no other problems exist. The report is a record of what was found today. It is not a warranty that nothing else will be found tomorrow. You have completed a residential home inspection of a newly constructed single-family home. During this inspection, you accessed and evaluated the roof, the attic, all 4 exterior elevations, the garage, the main electrical panel, and all accessible wiring, all plumbing fixtures, and the water, heater, the furnace, the air conditioning system, and all accessible ductwork, the foundation, and crawl space, all rooms on both floors, all windows and exterior doors, and all code-required safety devices. You documented 67 findings across 3 categories of severity. You photographed 218 images and selected 73 for the report. You spent approximately 3 hours and 20 minutes on the property and approximately 2 hours and 45 minutes writing the report. The report was delivered at 7:53 in the morning, 7 minutes before your promised delivery time. The house in this inspection is not unusual for new production construction. Inspection reports on new construction homes routinely document between 40 and 80 findings. Some of the findings on this list: the hollow core fire door, the disconnected bathroom exhaust fan, the absent chimney cricket, the non-functional smoke detector, are the kind of findings that a general contractor doing a final quality walk on the house should have identified and corrected before turnover. They were not identified and corrected before turnover. They were identified today by you, 3.5 hours after you arrived, because you worked through the house systematically and without shortcuts, and without the distraction of knowing the house was almost finished and it was Friday and the next crew was waiting. The value of a home inspection is proportional to the thoroughness with which it is conducted and the clarity with which the findings are reported. An inspection that misses the absent chimney cricket does not save the client from the eventual leak. An inspection that finds it but describes it vaguely in a report the client cannot understand does not help the client address it. An inspection that finds it, describes it precisely, photographs it clearly, and explains its significance in plain language, gives the client the information they need to negotiate its correction before they have closed on the property and assumed full responsibility for every defect the house contains. The house will be corrected to varying degrees. Some findings will be addressed promptly by the builder. Some will require persistence to get corrected. Some may not be corrected to the buyer's satisfaction and will become the subject of a warranty dispute. This is the reality of new construction. The buyer who had no inspection would not know which findings to pursue because they would not know what was wrong. The buyer who had this inspection has a 41-page document with photographs that describes 67 things, and they know specifically and precisely what each of those things is. That is what the inspection is for. Good night. The report was delivered this morning. The clients have read it. They are calling their real estate attorney. The chimney cricket has not yet been installed. It will need to be.